Well, welcome to Fundamentals of FMEA. This is a Ascendo Reliability webinar. And for those, I believe just about everybody that's on the line here, and I recognize quite a few names, uh, are familiar with the website Ascendo Reliability. I want to make just a quick plug for the podcast network that's part of that site. And you can find it at the URL reliability.fm. And there's 4 podcasts there on a one is on maintenance and reliability. There's speaking of reliability. There's a variety of discussions on topics, a range of different people, and a couple others. So if you get a chance, head over there and check that out. So today I want to talk about just really the basics of FMEA, just some of the starting pieces of this. And we all know that failures happen, right? We know that things eventually break. It's part of what keeps us in business as reliability professionals, and it allows us that basic knowledge from an engineering perspective is that whatever we're designing, a system, a piece of equipment, a home automation device, or a vehicle, or whatever it is there's an expectation that it will work. It will provide the functionality that the customers expect over some time period. And when that doesn't occur, the customer is likely to call that a failure. And we spend a lot of time in design understanding how it will be used, where it will be used, what kind of stresses it will see, and so on, in order to mitigate or prevent failures from happening. Well, as you know, there's lots and lots of ways things can fail. And part of what we're trying to do is anticipate or look ahead to what failures could possibly occur. And it was one of my favorite books called Design Paradigms by Henry Petrosky. And I should have put a link to that here someplace. Is where Henry Petrosky talks about that designers inherently design away from failure. Well, the caveat to that is they have to be aware of that failure. They have to know that something could go wrong, and then even better is what's the failure mechanism underlying it, so that they can make a conscious decision to mitigate or eliminate that potential failure. Now, one solution for this is not by far is not the only one, is to use this tool called failure modes effects and effects analysis. And what it does is it allows us to increase awareness and prioritize the potential failures for the device that we're taking a look at, or the element we're looking at. So it has a pretty decent way it can work to help us organize our thinking about what could fail. Now, here's just to add a number. I don't need to know the product per se, but take a look at the product you're working on, or the system you're working with, or even just look at your desktop or wherever you may be. Look at things that are around you, and what's a number? Drop it in the chat line. What's a number of how many ways something can fail? How many ways can what you're working on potentially fail? Hundreds. Yeah, thanks, Amy. Got it started. Anybody else? I'm looking for, how many ways do you think something can fail? Now, I realize this is kind of, I'm not sure it's a fair question, given that we're a bunch of reliability people that like thinking about failure, but 42, yeah, that's the perfect answer. I like that. Yeah, thanks, Dale. Describe failure. I don't define failure. Our customers do. The people using our products define failure. That's my take on it. And the failures we care about are the ones that cost us money. So a warranty, or call return, or loss of brand, loss of resale, any of those kinds of events that could cause a customer to cost us money. That's what I call a failure. Hundreds, 42. Um, this is kind of a brainstorming activity. It's one of the first steps you do in failure modes and effects analysis is, sure, hundreds and hundreds of ways. And the realistic ones, the most likely ones, go back to that Pareto principle that there's usually a few uh, that dominate how something's going to fail, right? Now, the hard part is well, which ones are the dominant ones? Now, I write that down. Usually one more way to fail than we can think of. There's plenty of stories about very creative customers finding unique failure mechanisms because they thought of a different, interesting way to use it. So one of the things I want to cover just quickly before we get into the basic steps is the value. Now, this part is something to keep in mind when you're deciding whether or not to do an FMEA study, to get a team together, to involve a number of resources in order to complete this activity or to engage with this activity. So the number one thing I believe FMEA does, and I'm certain you can disagree with me, but I think the number one thing it does is it sets priorities. And I believe I spelled that right. I had my spell checker choked on priorities a couple of times, and I hope I got it right. May have failed that. The idea, though, is that there's so many ways that a product can fail. And if one of the steps is to focus your resources, the engineering team, the diagnostics that we build into systems, the testing we do, a whole lot of what we do in development and in installation and as reliability and quality professionals is then focused on the most significant issues that we need to go solve. I use issues habitually. I used to work at Hewlett Packard. We didn't have problems. We always had issues or opportunities, as they euphemistically like to call it. But the FMEA process, it really is an ongoing process, is to help the organization focus and solve the issues or the failure mechanisms that could cause the most trouble for the organization. A second, so one way to think about this is just think of all the ways that this audio from this webinar could be broken. Now, a hard part here is that there's parts that we don't really know about unless you happen to be in the telecommunications industry. But if I could invest on improving the audio for this system, I'd have to include microphones and cables and computers or cell phones or tablets, cell towers, Wi-Fi or hardwired internet connections, the dozens and dozens of ways we're all connected. The infrastructure that carries these signals from node to node around the world. And then not only my end of it, but your end of it, and all of the various configurations of that, including speakers and headsets and so on. Now, we could individually across this industry work to make improvements on this. And right now, those decisions are being made by whoever owns that particular part of the system. Now, there are some standards bodies that try to go across those systems. There's a variety of other activities that help us get organized as an industry to make something like this webinar work. Yet, where do we invest the next $100 to make it better? And that's what I mean by the prioritization piece of this. If we want to improve our program, where do we need to focus? And that's this setting priorities outcome of the FMEA. Now, one question, I'm going to just mention this briefly, is FMEA talks about failure modes, and we often focus on failure mechanisms. And I'm going to just briefly define these, and then we'll touch base on this a little bit later. A failure mode is what the customer sees. It's the symptoms, is the way I think of it simplistically. Whereas the failure mechanism is what's causing, is underlying or initiating that particular symptom to manifest. So if I have a broken solder joint and I don't get a signal for a particular activity, then that would be a failure mechanism, a failed solder joint. Now, you could go deeper and say, well, it was a poorly made solder joint, a poorly designed solder joint. It was thermally cycling to a metal fatigue type failure mechanism. Could be all kinds of different levels to failure mechanisms. Yet, if I get no power to my desktop, and it because of a broken solder joint, the failure mode is no power, is a symptom. Now, we start with symptoms in the failure modes and effects analysis, yet we often are looking for and trying to ferret out what are the mechanisms so that we can do something about it. Another value part of FMEA is it creates alignment. So similar to priorities, but I have found in dozens and dozens of sessions I've worked with as a participant or facilitating FMEAs, is that the discussion across the table in the team, in of itself, independent of the final report or what our action items are going out of it, is that it creates alignment. So one quick story here is I was going into a session with one of my clients, and they made it's a robotic system for moving wafers around in a fabrication system. And the software manager grabbed me just before we got started outside the room, and he says, you know, we don't really need to do this. I know exactly what the problems are. Software is way understaffed. We're the choke point for this thing. We've got problems that will just devastate this program if we don't get them solved. So if we're going to be setting priorities, he said, I want you to know that it better be coming to the software team. I said, okay, well, coming in out from the outside, I didn't really know what the story was, whether it was software or something else, but I was glad he was in the room. So we had electrical, mechanical, and software representatives in the room and a handful of others. And it turned out by noon, the software guy recognized that the mechanical elements of this system were much more difficult and needed much more resources to solve than he did. So he backed away from trying to find resources and asking for more people or resources and started contributing to helping the manufacturing team solve their problems. Instead of fighting them internally for resources, he started contributing to the solution for the much more urgent and larger problems that other teams were facing. Now, that aligned a lot with what the action items were out of the program, but it, more importantly, stopped the infighting among the team for the scarce resources, because they now all understood and had a better appreciation of where the issues were and what really needed to get solved. And I'm not sure if you've seen something like that or not, but this concept of the team aligning in an FMEA is often one of the very few times that the team gets a chance to talk about the different types of failure modes and what kinds of problems the different teams are facing. And so this competing for resources part is just one facet of that. You may very well have seen some of the other ones. So I just ask real quick, maybe just a quick chat, is there a competition for resources in your teams, in your organization? This might be what do they call it, rhetorical question, but I suspect there is. And it helps you as an organization to get aligned, to get focused on where you need to focus your limited resources for the best effect. Now, a good program managers often do this anyway, right? Trying to align and make sure resources are fairly allocated for the max effect. Yet, it's often a very difficult subject to talk about the underlying issues and problems that are occurring that need resources to go to them, because there's a lot of unknowns in that whole process. FMEA is a really good structure for creating that discussion. Right. One more way that you can benefit with FMEA is to connect it to the rest of your program, right? One of the things that going through the process of asking, well, how many ways can this fail, or what could fail, or what haven't we thought of yet, or collecting how our information about what's the weaknesses of a product are across the team allows us then to become sensitive to what could fail. It allows us to include those areas that we're just not sure about. We don't have any real hard evidence that this widget is going to have a particular problem. Yet, if there's enough concern, even just to raise it up into as a line item in the FMEA, it's going to have unknown elements to it. We don't know how often it occurs. We don't really know what the magnitude of the severity is and those kinds of things. Yet now we're primed to see it when it happens. Now there was a study years and years ago I read about when I was doing a lot of bicycling on a road bike, and one of the ways that bicyclists get hit is that a person that's merging onto a lane, they look up the road to see if it's clear, and they just don't see the cyclist. They're looking for a car or a bus or a truck. And a bicyclist presents a very different profile to their line of sight. And even though they physically see me as a cyclist, they weren't looking for me. They were looking for a car on the road. And so they cognitively don't see it. Now, you may well have been working with a prototype or with a product and missed something that was a tell for a serious problem, right? A hiccup or a flicker or an anomaly or something unexpected that if you're not consciously looking for it or ready to recognize it when it occurs, it's likely you would miss it. Now, it goes even further. If I'm setting up a complex system and I need diagnostic tools to evaluate how the circuit responds or how quick something responds or how the interactions occur or all of the various mechanisms and so on function, if I'm not measuring them in some fashion, I may not even have the capability to detect a pending issue or an impending issue or a problem. And so FMEA has that ability to allow us to explore the areas that we don't know by the simple fact that it increases our awareness of what could go wrong and thus what we should be looking for. Right? Besides testing, what else can you use FMEA for? And I'm going to take away the one here, throw your ideas in the chat window, is that a customer requires it. And so it checks that box off. Now, I don't think that's a huge benefit, but if it's a condition of sale, it allows you to sell your product. That's always good. But what else is a benefit or a value of FMEA? I know, and I recognize a good number of folks that are joining today, and I know a lot of you have got great experience. So what's your thoughts on what else is a benefit of FMEA? Project confidence. Yeah, they have a good sense of what they know and don't know. Yeah, it builds into the design. It's one of the key tools for design for reliability, in my opinion. It allows us to get a good sense of where we've got issues. I agree with that, Michael. Minimize test time. I'm seeing that, Sanjay, in the questions tag. Yeah. And Henry, good question. I'll have to come back to that, is getting the right people around the table. That is a problem. Yeah, providing test case information you need. Yeah, knowing what the failure modes, Sean, that goes back to the sensitivity of what we're looking for. Yeah, potential issues for future designs. As you know, we almost never solve everything we can think of as ways things can fail. Future projects can certainly use that information if it's captured correctly or well so that it carries from year to year or from project to project. Lessons learned, exactly, good. Yeah, I think this get the surprises early is find out where you're going to have issues rather than in the last minute round of testing before you start production. It really adds a lot of value. Let's get this reliability thinking earlier in the program so that you have time to solve problems. It really does have. Yeah, maintenance procedures, good. It certainly does, Sean. It helps us understand the areas that we can't design out, the failure mechanisms we can't design out, say oil degradation, but then we could make sure that we have a way to support that. Yeah. Good question, Jason. We're going to come back to closing the issues here in a moment. Good, good, excellent. As you know, there's lots of ways of getting value out of an FMEA. There's also a few ways you can get it wrong and make it a complete waste of time. We'll touch on that a bit too. But very quickly, I'm going to pull the 10 steps to accomplish an FMEA and break it out into a couple different areas. So it's 10 plus steps. I didn't count the preparation ones. These are all from the basics. Let me pull up the cover here. The Basics of FMEA in the second edition by Robin McDermott and et al. From CRC Press. It's a little book. I think it's one I purchased anyway. It was about $10. And it's very short, very crisp, but provides just enough to get you and your team on the same page for getting ready for an FMEA and actually accomplishing it. Many organizations have an internal document or use a particular standard for their industry. That's all fine. Yet I found that the preparation piece is often a very, very critical element to have a successful FMEA program. Now, part of it is as you decide we're going to do an FMEA, and let's say we're going to look at roasting coffee, since I seem to have that theme going here today. If that's my process, is to create a good cup of coffee in the morning, well, do I start with the growing conditions of the beans or the roasting process, or which variety of prepared coffee I buy at the store? What's in scope for this process I'm looking at? And what's the purpose of this? Well, the purpose is, for me, is to have a consistently good cup of coffee in the morning. And is this a system or a product or a process? Well, it's a process, the way I just defined that. And whatever you're studying may vary slightly. And it changes just slightly how you go about doing the study. And for a particular product, you may do multiple FMEAs on different parts of the system or of subsystems or of particular components, and do those at different times or in a variety of different ways. It is a very, very flexible tool, as the McDermott book and the book by Carl Carlson goes into great detail about. This first step, though, is really define what you're doing. You don't just invite people, let's do an FMEA. You need to think through, well, what are we trying to accomplish here? What area do we want to study? What specific system or process, and what are its boundaries? What do we want to study? And then from that information, with a team leader identified or a facilitator, is, well, who do you need to invite? Who are the right people to get in the room with you? And Sean, if I remember right, you asked that question about getting the subject matter experts in. Now, it's not only the subject matter expert or the key designer. It's also, say, it's a mechanical process or like this coffee system. You know, I could get a barista in from the local Starbucks, yet that equipment and process is quite different than mine. Yet they may provide some insights because of their different training and knowledge about the process that would be very beneficial to improving my process. Or bring in my neighbors who also enjoy coffee, and maybe we can compare notes about what's particular about the process I'm using and so on. So part of it is picking a range of people that have some basic knowledge of whatever it is you're studying. They all don't have to be experts. And it's often good to have a few untrained eyes asking those simpler questions, which really, like Henry, is really getting out those issues. And then training. Does everybody understand what severity, occurrence, and detection mean in the variety of other terms that go into it? If they don't, you could do it during the session. It takes some time. Or you could hand them a book, the basics of FMEA, and maybe a quick training session to get everybody on the same language at least. And then organize the meeting. And don't underestimate that. It's often a hard part is to get 6 to 8 people in the room at the same time for a couple hours is a difficult enough task in and of itself. But that's some of the preparation steps. And the essential piece as you start planning an FMEA or you start to execute it because it's in your program plan or your reliability plan is how are you going to use the results? Do the people that allocate resources to solve problems, are they tied into this? Are they aware of the FMEA study and how they can use it as they manage the program, right? Or how will the results be used? If it's just to check off a box and send it to your customer, well, I have a different opinion of that. If it really is to help you improve your program, well, how is that going to occur? Who's going to use those results to actually do something and then support it, fund it, to make sure that that happens? So it's a key question to ask as you're setting these things up. And so these next 10 steps are straight from the basics of FMEA. Now, I have a few pieces of advice here as you go. If you sit down, you get your team together, you put them in the room, and you're going to go through the FMEA process. You're going to think about failure modes, all the other steps, and we'll touch those each briefly here. The basic idea, though, as a facilitator, is that there's a basic process to doing an FMEA, whether it's process or system level design or whatever. Follow the agenda. Stay on target, do the various steps in filling out the worksheet, basically, for an FMEA matrix, yet also be flexible. If you're really getting into some good material and good content and flushing it out real well, stay with it a bit longer. It's not a timed event in any particular realm. Yet on the other hand, if you're getting completely stuck and it's just diving into one random discussion after another, is pull back the team and change the agenda so you can focus on what you need to do. I was working with one team and we're working on a stack up from a circuit board through interposers through a socket into a chip, and we were trying to figure out where the problems were in that construction. And the hard part is that if there was an open circuit anywhere along that stack, we didn't have a way to tell where it occurred. Was it a bad pad? Was it in the interposer? Was it between the interposer and the socket, and so on? And so we stopped the discussion and spent our time trying to figure out how are we going to detect where the problem is without affecting the actual affection of the product. And so we shifted. We didn't have enough information to create a meaningful FMEA study because the stack up really only had 3 failure mechanisms: open, short, and intermittent. And every one of those had almost a dozen, I think it was 10 to 12 different locations that could occur, which would require different solutions to take action on it. And so it was very clear within a short time that we needed to focus on being able to sort out where the problems were in much more detail before we could create a meaningful study. And so this FMEA, it was actually pretty quick, and the action item was where we spent the rest of our time. And the hard part here is everyone participates. All too often, the subject matter expert dominates, or a manager dominates, or somebody dominates. part of the facilitator's role is to make it safe for everybody to participate. Well, let's go into some of the details. So you get in the room, you get started. Oftentimes, if you have a prototype or sets of drawings or a schematic or whatever it is that's representative of what you're studying, is do a quick review. Make sure everybody understands where the boundaries are of the study. So if I'm brewing some coffee, I'm going to start with the beans I buy at the store. And so that's the starting process. So which store, how long they're on the shelf, which brands, that's all part of the process, the initial decision that's made as we go through it. The final is is it in the right cup? Is the right type of coffee cup? I don't know if that affects the flavor or not. I suspect it does to some people. But let's define the process. And then it's the part I enjoy the most by far is the brainstorming. What could go wrong, right? And so for a coffee system, let's use the chat window. If I'm defining making a cup of coffee in my home kitchen, from the process of buying the beans to the first sip of coffee to test it, what could go wrong? What are the failure modes? You know, it's an inadequate brand to make coffee with my system. It could be stale or too old or not roasted correctly. You could go into all the different ways that just the beans themselves could be bad. And then there's what else could go wrong? What other ways could I screw up making a cup of coffee in the morning? I'm picking on coffee just because I happen to enjoy it myself, and I got a nice prompt the other day. Yeah, not the right temperature in the system. Now, it could be the wrong temperature where they store the raw beans, the wrong temperature of brewing the coffee or storing the coffee in my home. Yeah, plenty of environmental effects that go into controlling the quality of the overall process. Bad water quality, yeah, definitely. Contamination, yeah, that happens. Don't look inside my coffee maker. I know there's a filter in there, but yeah, the wrong mixture of water to beans, the wrong time it sits on there. Yeah, hey Kyle, enjoy your coffee. Too much water, too little water, the wrong temperature, the wrong dwell time on the grounds. The grounds are not the right size for the filter I got. Yep, forgot to wash the cup or just didn't. That could happen. Cup too full. How about stuff like cat fur gets into my coffee and interrupts the enjoyment of it? I have a house cat, which seems to enjoy spreading fur around. I guess that would be a contamination. Yeah, sorry about that, Dale. But it doesn't take long to do this. Now, here, I don't have 6 to 8 people that I can look at and say, has everybody participated? Now, I did see a couple new names in the chat window, so it branched out a little bit. One really good technique, if you know that you got somebody that dominates and pretty much shuts everybody else out, is do it silently. Have people use sticky notes and brainstorm pieces of that. And then the other thing that you saw me doing was anchor it. So what could go wrong with the raw material, the coffee beans? What could go wrong with storage? What could go wrong with the brewing process? What could go wrong with the delivery mechanism in the cup? Each of those anchors changes how we think about what could go wrong. Yet any idea and all ideas are good. It's the brainstorming rules apply, and then do a sort. Break it down, gather the similar ones, the duplicates, put them together, and so on, so that you end up with, say, 10 to 20 dominant failure modes that you want to go work on. And it's really your first cut. Is get a lot of them, clean it up so you get rid of the replicates and nonsense ones, and then move on from there. Brainstorming to me is the critical step. And for the value of finding what the rest of the team doesn't know. One person in your room may know the unique failure mechanism that's going to be a real problem, but there's not enough evidence to know if it's a real problem or not yet. But raising that awareness to the entire team allows you to analyze it. Right? And then next step is, well, if that failure occurs, right? If I get the grind is too coarse, like Michael's saying, if the raw beans are too coarse or too fine, let's say too coarse, well, what's the effect? What happens with that? Well, if they're too coarse for my system, it won't extract much of the coffee flavor out of the ground, so I'll get a weak cup of coffee. If it's too fine, I don't know what will happen there. It might make it too strong or too bitter or get too much mud in the bottom of the cup. I'm not sure. But that's where you start going, well, so what? What's the effect of that failure mode? What happens to the customer if that occurs? And we're looking for stuff from the range of that a cup of coffee would poison me. I hope that isn't one of the potential effects. But your product may be dangerous if it fails inappropriately, or a safety fails, for example, or if you're a single aircraft engine and the engine fails, right, or the wing falls off. Those are pretty serious effects. And it goes all the way to the list of, well, people wouldn't really know. So let's say it's a diagnostic sensor on my coffee machine, and if it doesn't work right now, I don't even know if there is a diagnostic on it, so I wouldn't really know. I wouldn't be conscious of that effect of a failure. Next is, well, what's that severity? So that goes into that, what's the consequence? And I use a 1 to 10 scale. Other standards use 1 to 5 or use a variety of scales, but it basically goes to, is this a life and death situation, or is this going to happen and be annoying? Is it going to be annoying enough that I have to make a different pot of coffee, or is it even noticeable? And so as you're going through assigning these severities, I know some standards say there's a fixed scale, and 9 and 10 are major damage and life-threatening and all those kinds of things. Yeah, Sanjay, I just noticed your note on too hot. If it's so hot that it burns my tongue, or I spill it in my lap and it causes second-degree burns, that's probably a pretty good severity. So, or a high severity issue. So the idea here is, what I was getting at is, if you're going through this process and everything is ranked a 6, it's not a great cup of coffee, and I'm not satisfied as a customer. Something's wrong. I'm not happy with it. Or a customer is likely to call customer support for servicing or for repair or return your product. Now that's rather severe. It's not life-threatening or anything, but it's a problem. If everything is a 6, then you're not getting any differentiation. And so one of the issues I've seen here is that we set up this fixed scale that spans from life and death to nobody notices, and everything's a 6. Well, one technique is then do, well, is it a 6.1 or is it a 6.4 or is it a 6.7? Or adjust your scales so that you get separation across the severity rankings. And this applies to all of the rankings, is that if you're getting everything is the same, you're losing part of the prioritization value of the system. This is that part where you need to be a little bit practical and flexible with the system. Now, I know in the auto industry for years, their standards were, here's the fixed rankings, so they could roll up studies from subsystems into the overall vehicle. Unless you're in that realm, in that requirement for your system, one way to ensure you get the most use out of your study is to make sure that you have spread in the scoring that you do for severity, occurrence, and detectability. All right? So as we get these different failure modes and their associated effects, is, well, how often will the failure mode occur? What's the occurrence? How often will it occur? Will it occur every minute or every time I use the product or make a cup of coffee? Or will it occur only once every 6 weeks as my storage problem with my raw beans affects the quality of the cup? So it only occurs once a month. Or maybe it's only once every year as I realize I should really change the filter in my coffee pot. Um, how often does this problem occur? Now, this gets complicated because different people using your product or different people making coffee will have different habits or processes they're using or different environments they use it in. And so thinking through as your fleet of products going out to the customer, or make it clear that it's for a customer. How often would this occur? And so some people try to rely on failure rates for different parts of their system. I, unless you have really good data at the subsystem or component level, um, rely on your engineering knowledge as a way just to separate the occurrence ratings and rankings. It's one way to do it. So then probably the most confusing part of an FMEA for most of the teams I've worked with is this detection ranking. And so this part encompasses two different concepts in my mind, and I've seen it in a number of different references, is that the concept is, can I detect that I'm going to make a bad cup of coffee before it actually occurs, before the consequences occur? So think of the oil light on your car. If I get an oil light indicator, it indicates that I don't have enough lubricant in my engine, or is there something wrong in that lubrication process? And if I don't address that, add more oil or replace it, the engine will be damaged and maybe have to be replaced. It'll seize up. And so if the oil goes bad, which is a failure mechanism, or there's a leak and it drains out, I don't get enough oil pressure, then the consequence is that it'll destroy my engine. So this detection piece allows me to interrupt that process and avoid the consequence. So that could be built right into the product. So I don't believe my coffee pot has a little marker that says that it's in the right temperature range, right? That there's something wrong with my sensor. They didn't deem that as being good enough to do, right? And so in Ted, to your question on detect the failure or the cause of failure, it depends, right? If I've got a low oil in my vehicle, I'm detecting the high likelihood that I'm going to have a serious damage to the engine. If the heater in my coffee pot is broken or is degrading or corroded or something such that it's not able to hit the right temperature anymore, it's already happened. The failure is already there. I won't have the right temperature. So that gets into the technology of what you're working on, right? And so it's going to depend on the understanding of the failure mechanism. Is it a degradation process? Is it provide warnings? Is there symptoms or indicators of a failure mechanism coming or pending? And on and on and on. So like on my car, it tells me when one of the tire pressures or one of the tires has low pressure. And it'll tell me that if it's just 2 psi below the threshold or if it's flat. So it really depends on how the tire lost the air, whether it's going to tell me in time or not. And so it's not going to tell me that there's a nail coming up and I need to turn left. It will tell me that there's not enough air in the tire. So it really is tied to understanding the failure mechanism and how it manifests itself for these onboard, on-system detection systems to work. We're seeing more and more of those indications and diagnostic routines and so on that give information to the user so they can make decisions about maintenance and or operation. The other way detection works is in the development process. Can we determine whether the manufacturing for this component is capable or not. And if it's not, it affects the product's performance, and so on. Can we find it in our verification and validation testing? Do we have a way to detect it? Now, I don't think that's one way to go to find out, are we sensitive to this problem or not? Can we tell if it occurs or not? Yet, if we can't design it out of a product, then that second, the first one I talked about, of onboard detection or diagnostics may be the way to go. And so if I have a bad solder joint and I'm doing a circuit board test that looks for opens and shorts, I may be able to detect that bad solder joint. Sometimes those joints are intermittent, and I may not always be able to detect that. So it would score as some mid-level ability to detect. The other piece on detection is that it's a reverse scale. The ones that I am not able to detect until the consequence occurs get a high score. So the less able to detect, the higher the score. Whereas if something occurs more often or something has a high consequence, they get a high score. So it's a little bit of a flip on the scale. And then tally up the risk priority number, which is the product of the severity, occurrence, and detection. And that provides us a way to sort, rank, order these things. One caveat on here is to look for those things that are groups of similar underlying problems. So I might have a relatively low RPN number, say for solder joints, yet collectively there's a lot of solder joint problems. And if I implement an improvement in my soldering process, I could fix a lot of different things and reduce the chance of a lot of different problems occurring. So the things that are high severity that cause harm or serious damage, independent of their risk priority number, those get prioritized. We need to address those. Keep it safe. This ties into the safety part of what we do. Then the next is the high priority numbers. And then the next is the low-hanging fruit, the things that are easy to do that would have a pretty good return for the investment to make the improvements. And then all of that is for naught unless you follow up. If you only discuss the problem and you create a report or you create these RPN numbers and you file it away in a cabinet someplace, there will be some residual value of people having those discussions. Yet it's not as effective as you actually create those action items to reduce the high-risk failure modes, the elements with the high RPN numbers. And so this action item step is critical, and it has to be backed up with the resources to make it happen. Yeah. So David, I believe I just saw your note about the design process. I hope I mentioned that. Part of it is, can I detect it in my simulations and my prototype testing, in vendor qualifications, things like that. So these actions may include fix this problem, eliminate this failure mechanism, change the material, redesign the filter so that it has a warning when it's expired, for example. Or it's going to be, we need more information. We don't really know how often something occurs, so let's do an experiment or gather more data and then update the RPN numbers. So you got to take the action, and then as those actions are accomplished, recalculate the RPNs, resort to find out what's the next thing to work on. And this part, the step 10, is often the one that I don't see done. And I'm sure there's people that do it on a regular basis, but I'd say that's more rare than common. Yet it's a critical piece to close the loop on your process to make sure you quantify the resulting value that your study did. It also helps you look for if you missed anything. It's that regular review of accomplishing the action items, and then did they have the desired effect? So can you change the risk priority numbers? And so while it's hard to do, given the many things we've got on our plates to do, It's also a really good tool to make it happen. Now, I don't have a coffee. This isn't my coffee pot at home. I have a much, much simpler one, also a lot less shiny. But it does work pretty well overall. All right. So let's quickly mention some of the ways this could go wrong. One of my favorites is, oh, we need to do FMEA. So George, you go over here and you fill out this form. George may be very competent and very much know how the product can fail and fill out this form. Yet Sarah and the rest of the team also have views that George may not have. And it's that combination of different people looking at a product or a process that allows us to benefit the most from this process. Just filling out the spreadsheet, filling out a form, coming up with RPNs is not the objective, right? It's that team interaction, it's the alignment, it's the ferreting out things that collectively we did not know, but individuals were aware of. It's the prioritization across the team that's important, not just one person filling it out. By far, my favorite example of this was a client that said, "Oh, we're required to do FMEAs in our contract, it's a military project," and so they outsourced it. And he says, "Well, how do you use the study? How do you participate in creation of it, or do you use it?" He goes, "Oh no, our consulting group that does the study for us sends it to our customer, and they check it off the box. It's done." Whereas the customer probably expected them to do FMEA so that it would actually improve the design. And instead it got interpreted to, well, let's do it the cheapest way we can just to get it checked off on so we get paid. And it completely missed the value of FMEA and probably the intent of why the customer was requiring it. So just one person doing it or outsourcing it loses a significant amount of the value of actually doing this process. The other one I've run into is that you start with a bill of material and you do every single solder joint. So let's do the right side of this resistor, let's do the left side of this resistor, or every individual capacitor. Well, capacitors fail open, short, or intermittent, or their capacitance drifts. I don't need to study each individual of the 1,000 capacitors I got in my system of each individual one and record the exact same information over and over again. Some of the online or the software-based FMEAs make that part much quicker, yet do you really need to look at it that way? Let's start from the top down and start with that failure modes and sort out what are the mechanisms that we really need to be concerned with. Work our way backwards for that. Yeah, emulation is a great tool to help us sort out where we need to be focused. And there's no way we're going to solve every issue listed. But let's do a process that gets us the top 20% of issues with a pretty reasonable chance that those are the top 20, rather than looking at a couple tens of thousands of issues and sorting it out to 20. Let's look at the top 100, 150 and sort it out to the top 20. And then obviously if you just do the study and put it on the shelf and nothing happens, then you've wasted your time and wasted your team's time. So going back to the start is lining up that support, lining up the resources to take action, to do the studies, the research, the experiments, the testing, and changes to the design is critical in order for this process to work. So if you're late in the program and somebody says, oh, we should do FMEA, well, the question to ask is, can you change the design? Is there room to improve components or the process, the assembly process, or whatever it is you're working on? If there isn't, there's little point in doing an FMEA. And so you have to be able to take action on the results you're seeing. So we've got a couple minutes here, so I'm going to take a look at some of the questions. I'm seeing a handful of comments coming in. So how else can they go wrong is always an open-ended question I like to ask because I learn stuff every time I ask that. And so, yeah, I didn't mention that as part of the makeup of the team. Oftentimes is to include one of your key customers. If you've got a good relationship with somebody that really understands your product and you're looking at it as a system level, they may provide that insight that you just don't get on the design team. And same with suppliers. I did that a number of times with different suppliers, a power supply in particular. And about an hour into the session, the supplier engineer looked at us and said, I didn't know you were using it that way. Let's look at that circuit again. Here, we need to, look at this, this, and this. And here's what could happen if you use it that way. And cleared up a misunderstanding of how to properly use their component or what they were selling us how to actually use it. Yeah. Yeah, David, is one of the ones I ran into is everybody in the room had a different training. They came from different organizations and companies. And we spent more time arguing about definitions and how to do an FMEA than just actually doing it. That was a challenging one that I ran into. Yeah, good one, Amy. Yeah, it sometimes the FMEA can be. I've seen it used as part of a problem-solving tool or sequence. Is you get together with supplier, transporters, assemblers to look at that as a process and use the FMEA to focus on where you can make it better. Sometimes it's that simple communications that solve problems. Other times it's a bit more trickier in a filter blocks rather than what causes the blockage. Yeah. Um, part of that, Henry, too, is it's tricky. If you're at a very high level, filters are blocked is good enough. But if filter blockage turns out to be a higher RPN number, then it might be worth a secondary FMEA, just looking at the process where the filters are, how they're designed, what they're seeing, and so on. But yes, having that balance without diving into all the nitty-gritty details is tricky a lot of times. But if you're looking at just the airflow of your system, that filter is pretty critical. If you're looking at overall filter or system functionality, if the filter doesn't cause major overheating, doesn't happen very often, it may not be worth spending time on it to understand it in more detail. So you got to make that call as you're in the moment with these studies, is to how much detail to get into it. So if it's trending to be a top hitter, get more details, and so you can create good action items, or spin it off to a separate study, especially if it's a complex problem. Yeah, getting operators on board. I worked with a factory canning factory that had operators, the equipment suppliers and designers, maintenance team. It was a great discussion, and the entire team learned quite a bit. So in summary, FMEA is a wonderful tool. It has a range of different values when it's used appropriately. It's critical to get the right team together and set the stage so you're successful. Get that support so you can take action on what you find. There's a 10-step process. It's straightforward. It's in just about every standard I've seen on FMEA and every book. A common set of definitions, a common set of examples, a common training for your team so you're all on the same set of terminology, if nothing else. And then be flexible. Allow your team to benefit from the process rather than just struggle through it. Doing an FMEA is not the challenge. It shouldn't be the challenge. Is using the collective knowledge of your team to improve your product is the challenge. And then make sure you do the follow-up. Get those resolutions. Get the pieces you need. So let me pull up the conclusion slide here. There we go. And so you can get to the slides and some of the other contact information and stuff. Um, and let me check to see if there's any more questions and comments in here. It looks like that's been pretty busy. Yeah. Get scary.